Your regression is done. You have an equation, a slope, and R squared. But here is the big question. Is that result actually real or just lucky noise from your sample? Today, we find out using hypothesis testing, t-tests, f-tests, and how to know if your whole model is significant. Remember Sarah's Cafe. Our regression says for every extra 1,000 ringgit on Instagram, sales rise 4,800 ringgit, but we only have 15 days of data. What if those 15 days were just a lucky stretch? Two possibilities. Instagram really works, or we just got lucky. Hypothesis testing decides which one it is. Every hypothesis test starts with two competing statements. The null hypothesis, H0. Instagram has no effect on sales. The true coefficient is 0. This is always the boring assumption. Nothing is happening. The alternative hypothesis, H1. Instagram does affect sales. The true coefficient is not 0. This is what we are trying to prove. We assume H0 is true, then ask, is our data surprising enough to reject it? The first test is the t-test. It tests one coefficient at a time. The formula, t-statistic equals coefficient divided by standard error. For Instagram, coefficient is 4.8. Standard error is 1.11. 4.8 divided by 1.1, 1 equals 4.32. That is far from the null of 0. Rule of thumb, if the absolute value of t is greater than 2, the result is likely significant. 4.32 is well above 2. Good sign. The p-value turns the t-statistic into a probability. The p-value is the probability of seeing this result by chance. If H0 were true, for Instagram, p equals 0.002. If Instagram truly had no effect, there is only a 0.2% chance of seeing a coefficient this big by random chance. The decision rule is simple. P less than 0.05, reject H0, statistically significant. P greater than or equal to 0.05, fail to reject H0. Not enough evidence. Instagram, P equals 0.002, reject H0. Instagram spend has a statistically significant positive effect on sales at the 5% level. The t-test checks one coefficient. But what about the whole model? That is what the f-test is for. The null hypothesis for the f-test, all coefficients are 0. The model explains absolutely nothing. Sarah's result, f equals 23.45. Significance f equals 0.001, less than 0.05. Reject the overall H0. The model as a whole is statistically significant. Important rule, always check significance f first. If significance f is greater than 0.05, the whole model is useless. Let me put t-test and f-test side by side. T-test shows whether this variable matters, one coefficient at a time, found in the coefficients table. On the other hand, the f-test shows whether the whole model matters, all coefficients together, found in the ANOVA table. Both use the same rule. P less than 0.05 means reject H0. Always run the f-test first. No test is perfect. Two types of mistakes are possible. A type 1 error happens when we reject the null hypothesis when it is actually true. We claim Instagram boosts sales, but it was just a lucky 15-day run. By setting alpha equals 0.05, we accept a 5% chance of this mistake. A type 2 error happens when we fail to reject the null hypothesis when it is actually false. The problem can be fixed by collecting more data. Larger sample, better detection. 3 common mistakes. Mistake 1. P equals 0.002 means a 0.2% chance. Instagram has no effect. Wrong. Correct meaning if H0 were true, there's a 0.2% chance of seeing this result by chance. Mistake 2, F test is significant, so all variables must be significant. Wrong. F test checks the overall model. You still need individual t-tests. Mistake 3. Not significant means zero effect. Wrong. Not significant means not enough evidence. It does not prove zero effect. Here is the complete written answer for hypothesis testing. For the F test, F equals 23.45, significance F equals 0.001, less than 0.05. Reject overall null. The model as a whole is statistically significant at the 5% level. Instagram t-test, t equals 4.32, p equals 0.002, less than 0.05. Reject the null that B1 equals 0. Instagram has a significant positive effect on sales, holding day type constant. Weekend dummy t-test, TE equals 4.81, P equals 0.001, less than 0.05. Reject null that B2 equals 0. Weekend days significantly differ from weekdays, holding Instagram constant. Conclusion. Both variables and the overall model are significant, not due to random chance. Always note 5% type 1 error risk, accepted by setting alpha equals 0.05. For hypothesis testing, always follow these 5 steps. Step 1. State H0. Step 2. Check the F test first. If significance F is less than 0.05, the overall regression model is significant. Step 3. Check the t-tests. Check the p-value for each variable to see which variables have a significant effect. Step 4. Make the decision. If the p-value is less than 0.05, we reject the null. The result is statistically significant. Step 5. Remember the error risk. At a 5% significance level, we accept a 5% chance of making a type 1 error. Your turn. A student runs a regression. Y is exam score. X1 is study hours. D equals 1 if tutored, 0 otherwise. Study hours. T equals 3.85. P equals 0.002. Tutored dummy. T equals 1.50. P equals 0.16. F stat equals 18.2. Sig. F equals 0.003. Adjusted R squared equals 0.78. 4 questions. 1. Is the overall model significant? 2. Is study hours significant? Write the full conclusion. 3. Is tutoring significant? What does P equals 0.16 tell you? 4. Write the complete hypothesis test conclusion for the whole regression. Pause now. Try all 4. Ready? Here are the answers. 1. Yes, the overall model is significant. Significance F equals 0.003 less than 0.05. Reject the overall null at the 5% level. 2. Yes, T equals 3.85, P equals 0.002. Reject null. Study hours has a significant positive effect, holding tutoring constant. 3. Not significant. P equals 0.16. Fail to reject null, not enough evidence. Does not mean zero effect. 4. F equals 18.2. Significance. F equals 0.003. Model significant. Study hours significant. Tutoring not significant. Model explains 78% of variation. If you got all four, well done. That is hypothesis testing in regression. T-tests tell us about individual variables. The F-test tells us about the overall model, and the p-value helps us make the decision. Next time, we will discuss logistic regression, how we predict yes or no outcomes using data. If this video helped you understand regression better, don't forget to like and subscribe. And leave a comment. Which one confuses you more, the t-test or the f-test? See you in the next one.